When working in a DevOps space, you are always in the lookout for tools that will help automate and simplify the way you do software and infrastructure development. A number of these tools involve services that are exposed as web applications. And in a series on my channel, I showed one of these web applications, and this is runatlantis. The runatlantis service that I have set up is readily accessible through the internet, meaning anyone will have access to the logs and components on this service that contain infrastructure-related changes. And we know fully well that infrastructure is the heart and soul of a system. And with my current setup, I'm making my system highly vulnerable to attacks. Having said that, I need to make changes to my runatlantis service so that it's not readily accessible through the internet. I need to find a way to authenticate and authorize anyone who attempts to access my runatlantis service and be able to protect my assets from potential attacks. Hello, I'm George and you're on Pablo Spot, a space where I show and tell practical examples and sample implementations on DevOps and cloud technology in general. In today's episode, I will make the necessary changes to make sure that users who attempt to access my runatlantis service in the internet are properly authenticated and authorized. So, let's start coding. Last time, I have set up an ECS infrastructure to allow my runatlantis service to be accessible through the internet. I have major concerns about this setup though. First thing is that I don't really want everyone to see the logs of my Atlantis service. These logs contain information on how I have set up infrastructure, and allowing everyone access to these is a major security flaw. I want to be able to set up a way to get users authenticated properly when accessing my Atlantis logs. And because I have been using OKTA already, I can make all the necessary configuration changes on my Atlantis infrastructure to authenticate users against OKTA before getting into the Atlantis logs. This repository that I have loaded on my VS Code session is the one that I used to set up my runatlantis service. I will try to simplify the process as much as I can, but if you want to gain a better insight on how this is set, watch this episode right here where I updated my load balancer to force OKTA authentication. Meanwhile, let me go ahead and open my main.tf and head all the way to the end of this file. The first set of resources that I need to create to enforce OKTA authentication are OKTA related resources. So I'll start with the OKTA app auth resource. This resource needs a label which I will set to an arbitrary value and call it Atlantis OIDC. I also need to set the type property to web. And also add omit secrets property and set this to false. This resource also needs grant types property which accepts a list. And I will add the authentication code string inside this list. I also need to add another property called response types, which also accepts a list. And inside this list, I will add code. And lastly, I will add another property called redirect URLs property, which also accepts a list. And then add the IDP response endpoint that will point to my Atlantis URL. And now that I have an Okta app OAuth resource, I also need to add the Okta app group assignment resource to grant permission to the Okta app resource that I've just set. This resource will need an app ID property, which I will point to the ID of the Okta app OAuth resource that I just created previously. I also need to add a group ID property, which I need to point to an existing Okta group ID. And in order to set this group ID, I need to head to my data.tf. And I need to define a data reference that will pull an existing Okta group resource with the developer as the name. And now let me head back to my main.tf and then update the data reference. And now that I have set up both Okta resources, I can then start updating my ECS module to pass my Okta authentication details. And so let me head to my ECS module. First things first, I need to change the version I am referencing here to use the one that contains support for OIDC. So I will change this version right here from 0.12.9 to 0.12.10. And now I will add new property called authenticate OIDC details to set up all the necessary information that I need for my authentication. This property is an object with several properties which I need to set for this to work. I'll start with the client ID property. Which I will set to point to the client ID property of my Okta app OAuth resource. I also need to set the client secret property. And this one, I will fetch from the client secret property of my Okta app OAuth resource. And then lastly, I need to set the OIDC endpoint property. And for this one, I need this to point to my Okta base endpoint. I have this Okta base endpoint stored in my parameter store record in AWS. And so in order to pull this, I'll head to my data.tf and set a data reference for an existing parameter store record. And then I will pull the record where the name property points to tool OKTA org URL. And now back to my main.tf. I can then update my OIDC endpoint to point to the value of my OKTA org URL data reference. Before I start pushing my changes to my actual infrastructure, I just remembered some changes that I need to do. This is probably something that should have been done way earlier, but I need to set up my backend to be able to integrate with OKTA. And so on my backend.tf, I need to add OKTA as a required provider. And then on my providers.tf, I need to define the block that will bridge the integration between Terraform and OKTA. I need to set the org name, base URL, and API token inside this provider block. And the values for each of these properties will be derived from parameter store records in AWS. So let me head to my data.tf. And then in here, I will define all the necessary data references that will pull the values for me from the parameter store. So I'm going to start with org name. Which I will fetch from parameter store with the name tool OKTA org name. And then let me duplicate this data reference to fetch the other properties. For the base URL, I am going to fetch the value from the name tool OKTA base URL. And let me duplicate this one more time to fetch the value from my API token. And then this time, I'm going to pull the value from tool OKTA token. And then now back to my providers.tf. I can then update the values for the properties inside the provider to fetch from the data references that I have just set. And now, let me open my VS Code terminal. You might find this interesting because this might sound like a catch-22 or chicken versus egg situation. But because I am updating my runatlantis infrastructure, it's just safer to do this the old-fashioned way, which means I will go ahead and export my TF workspace. And then initialize my AWS credentials with AWS Vault. and then start running my Terraform commands. And now that I have successfully applied my infrastructure changes, let me switch to my browser and attempt to access my runatlantis endpoint. And now I'm being redirected to Okta to get authenticated, so this is good. My Atlantis service is now being protected. I would not want this to be readily available and accessible to the public. Like I pointed out earlier, this endpoint contains information about the underlying infrastructure, so it might be best to allow access to this only to authorized users. But with this change, I have a new problem. If I go to one of my GitHub repositories with a set of changes waiting for a pull request, so what I'm going to do is I will raise this pull request pending in here and attempt to trigger my infrastructure plan automatically. And so if I head down to the check section of this pull request, the Terraform plan on my Atlantis service does not get triggered. Remember that I have set up a GitHub application to manage the interaction between GitHub and my Run Atlantis service. And so if I head to my Run Atlantis GitHub application, and then head to the advanced section on this page, and then click the first recent deliveries on the list, and then click on the response tab. Notice that the response payload contains a URL that points to my Okta endpoint. So what happens here is that my integration is also trying to get authenticated against Okta, which is incorrect. So what I need to do to fix this is head back to my VS Code, I need to update my ECS module and add a new property called LB authentication exclusion or load balancer authentication exclusion. So somewhere in the ECS module block, which is right here, I will add this property. Under the hood, what this property will do is set up a load balancer rule that will be excluded from the authentication rule that I have set up earlier. So inside this property block, I need to set up a few load balancer rule related properties such as header names, path pattern, and request method. All of these properties are accepting lists as a value. So let me start updating the path pattern. For path pattern, I will add exclusion for the events path, which is what GitHub integration will call during the integration. For the request method, I will add post method, which is the method that GitHub will use when calling my Run Atlantis service. And lastly, I will add the xhub signature as one of the header names to be checked as part of the exclusion.
All these values here that I set are properties of a request triggered by GitHub when calling or integrating with my runatlantis service. So now let me open my VS Code terminal and update my infrastructure. Let me now switch back to my browser and head to my open pull request, which is right here. And this time, I'm going to attempt to trigger an Atlantis plan by heading to the comment section of this pull request and key in Atlantis plan. Notice that the GitHub has managed to successfully integrate with my Run Atlantis service, as indicated by the Atlantis items inside the status checks on this pull request. And this is the interesting part. If I go ahead and open the details link next to the Atlantis plan item, the page is asking me to be authenticated via OKTA. So I can no longer go straight to the logs of my GitOps process and see all this information about how my infrastructure is going to be applied or updated. So let me log in using my OKTA credentials. And now I can start viewing the logs of my Atlantis run. And that's all I have for today. Let me know your thoughts in the comments below and send me some likes if you find this useful. And don't forget to hit the subscribe button if you like the content on this channel. Until next time, keep learning and stay safe. See ya.